Okay. Now, over the last 2.5 weeks, we have been talking about fundamental concepts about design, fundamental concepts of design, and we have been, starting off with something as simple as objects and going all the way to 4 principles of abstraction, encapsulation, inheritance, and polymorphism. And, the other day we talked about, how we can once we have identified the potential classes, we should start with the behavior first, identify the behaviors, and then go on and set up all the other related relationships. So we stopped somewhere here, and I think I'll just use this as a starting point again. We said that we can have static variables and methods, and just to make sure we all understand this, in UML we show them as underlined and kind of bold form so that you can distinguish that these are static methods or static variables. So this is something we talked about the other day on Sunday. So let's move on from here and talk about other very important and fundamental design decision concepts. They are the basics yet. We have not gone into advanced concepts yet, but we're still trying to make sure that when it comes to basics, all of us are on the same board. So again, I believe for this one, you have been using this from your ICS 1 or 2 or 5 days, and it will refresh the memory. And B, I usually do this because I want to make sure that we are absolutely clear about the inheritance concept, and when I can create inheritance and when I should not create inheritance. So it's actually, at the end of the day, it's more like an is-a relationship. And basically, some of these examples could be that a car is a vehicle, a bus is a vehicle, but then you can ask and question yourself something like this: a car is a bus, right? For example, like, can I have an inheritance relationship between car and a bus? So depending on the answer to this question, you tend to have inheritance relationship between these two objects or not, or classes or not. Similarly, another example could be that employee is a person, or you can say a customer is a person. And then you can always question yourself whether customer is a shopping cart, right? So you can have these kind of questions in your mind when you're designing the relationships among classes, especially the inheritance relationship. And depending on the answer to this question, basically, you can go on and create inheritance relationships. Another example could be, you can have different kind of account types, and you might say that a checking account is a kind of an bank account, right? And you can have a savings account, and there's also like a type of a bank account. Or you can even have multiple layers of inheritance, like for example, Bentley is a car, and then a car is a vehicle as well, right? So far so good, right? I'm pretty sure you guys know this.
Yes.
Okay. So let's go to the next one then. Now, for example, we have these different potential classes in front of us, and you went through the exercise we went on Sunday and you came up with them. And now as a designer, you're my like team leader, and I'm a new designer, and I come to you and say, I believe I can create an inheritance relationship between bank and bank account, because I believe, bank account at the end of the day, is part of the bank, isn't it? So can I do this? Should I do this?
I think no.
Why not? It's bank
Yeah,
account
no.
is there in the bank, right? Isn't it?
Yes, but it is
Yes.
not a bank. The bank account is part of the bank, but it's not a bank.
The bank is more general. Like you can have many things, but the bank account is a part of it.
It's a part of it. So is it, since I have, because I'm confused here, like as a new designer, that since it's a part of it, maybe I can have an inheritance relationship here, right?
I think that a bank account is an independent object. So we can open a new account for each customer from this class.
Mhm.
Not
So
related.
yeah, so as Ali said, it's not the same. It's not of the same type. It has a relationship, right? Okay. So yeah, you guys are right, absolutely right. Uh, we should not have this. Of course, we have the checking accounts and saving accounts. Probably they will have some kind of an inheritance relationship, but we cannot just have an inheritance relationship between bank and bank account. Yes, for sure, they have some relationship, but it is actually, not an inheritance relationship. So there might be a relationship, as you guys said, but it's not really an inheritance relationship. It's something else. So this is the reason I bring this example here is just to make sure that this design, the four basic principles we talked about the other day. Inheritance is one of them, and even when I was talking about inheritance there, I said this a couple of times that you have to be absolutely clear that they should be of the same type. We cannot mix and match apples with oranges. So on the other hand, can I have an inheritance relationship between these two? Am I allowed to do this?
Yes.
Yes, it's okay.
Right. It's okay, right? Because checking account at the end of the day is a bank account, right? And so is this one, right? The same account. So if I'm allowed to do this, naturally, I can come up with a relationship like this. So I can have a bank account, and these bank accounts can have checking accounts, children saving account, or investment account. And we all know this, by the way, that whatever is defined in the parent class is available to these children. And of course, these children, in addition to these ones, they can have their own attributes, they can have their own methods, and so on and so forth. Easy
Sir,
stuff. Yes, please go ahead.
is it good practice to think about it from the coding perspective, like saying that if they are inherited, they should kind of have the same behavior? Is it a good practice to think about it this way?
Uh, if I would say then and then I will answer in this way. Basically, regardless of the process model, you want to have some kind of a design before we do the coding, right? So from that perspective, it's your decision as a designer that you will say, well, because they have a common behavior, I'm gonna make them as parent, and hence the source code has to be in line with this decision, right?
Yes.
Yeah, and of course they go hand in hand, So based on and the reason you're gonna suggest this as a designer because of your experience of source code writing in previous projects and so on and so forth,
Yeah, yeah.
right? So of course, we all know this, and a lot of people recommend this again and again. Avoid unnecessary multiple level inheritances. It is a concept which is allowed, but it's not really recommended. Uh, Now, for example, you may also come up with across another example, like you have an album, book, and movie. So you can actually go on as a designer and decide to maybe make something like a product class as a parent class, right? Because you believe as a designer that album, book, and movies are going to have the title and price, and these methods are going to be common across them. So why not I just create a parent class here, and of course these children can have their own attributes and methods anyway. So this is your design decision, and this is the way you basically uh, as long as they are of the same type and they have some sort of an easy relationship, you can go on easily and create inheritance relationship between them. The only thing you have to be careful about is make sure they are of the same type. Of course, a couple of slides ago, I said that multiple inheritances should be avoided where possible, and surprisingly, in Java itself, everything is inherited from object, right? So you have multiple inheritances. Uh, Only message here is that don't use it unless you absolutely have to use it, and if it is really required, go ahead and use it, but don't unnecessarily create multi-level inheritance structures, because that will become harder for you to, to maintain, to update, and so on and so forth. Now, what will happen when you write a class that never get initialized? To begin with, is it possible that I can have a class that we never create an object of it?
I think yes.
I
It's okay.
guess yes.
Now, why I will be interested in doing that?
Maybe it will be spaghetti food or something like that.
If it was a parent class, I will not make an object from it.
Or an abstract class.
Or an abstract class, right? Now,
yeah.
Yes, go ahead, please.
Like for example, the bank account. Just
Yes.
make it, but you make saving and others classes to inherit from it.
Exactly. So the abstract class is the concept. Go ahead, please.
There is type of classes. I forget those. I forgot its name, but we can define it when we want to use it. So we don't have to create instance of it.
Okay.
Like for buttons or something like that.
Exactly. So basically, as you guys said, bank account, and then you have checking account, savings account, and investment accounts. But you might realize, and by the way, even during the code, you might realize it, or if you are more experienced as a designer, you might realize it that yes, there is a relationship between them. And for sure, they have inheritance relationship. But at the end of the day, whenever I'm going to use an account, I never really use a bank account object at all. I always use these specific ones, right? Because at the end of the day, there's no such thing as a bank account. An account is either a checking account or a saving account or an investment account, right? So what to do with this class then? Because I'm never going to create an object out of it. Do I really need this one?
Only for design
for the common
purposes.
attributes.
Yeah, for the common attributes, right?
Yes.
So if it's never going to be initialized, of course, then what I'm going to do? Can I specifically tell to the programmers that don't initialize an object out of it?
Should we
make it abstraction.
Yeah, make it abstract.
Should we make it an interface, Doctor?
That's a good question now. So I'm going to come to interface very shortly, right? And then we'll compare these concepts. Absolutely. But for the time being, let's concentrate on this, and then we'll compare it in maybe 10-15 minutes, inshallah. So one way of doing it is basically we go on and create abstract classes, right? And the moment you say something is an abstract class, basically, it's purely exists for sake of inheritance, right? So you want to make sure and somehow structure it in such a way that the common functionalities are shared with your children, with the concrete classes, right? It's only exists to provide the shared behavior. That's the aim of it, and you basically you use the word abstract, for example, in Java, and the moment you're going to use this word abstract, keyword abstract with a class, programming languages like Java will not even allow you to create an object of this. Correct? I'm pretty sure all of you guys have used abstract classes at a certain stage.
Yes.
All right. Okay. So of course, if this is an abstract class, then these classes are naturally your concrete classes because you can go on and create objects of it. Okay. Any questions, guys, on an abstract class before I move on?
How we can represent abstract in UML?
Good question. There is no as such a an annotation as such, right? I think abstract class probably has a tag, I think so, if I'm not mistaken, right? Which shows that, with the keyword abstract. Sorry, let me write it here. I lost my pen here. Something like this with a tag. Anything else, guys? Any question on abstract class?
Yes, Victor. Can we say that from this chart, the parent class is always abstract class?
Oh, good question. No. Now, the parent class is not always gonna be abstract class. Okay. The parent class. So in other words, if whenever you're going to have an inheritance relationship, it does not mean that always parent will be abstract. Parent will be abstract in a case like this, where you're never going to create an object of them because that object doesn't make sense in your application. It's like, for example, here a bank account, an object of a bank account really is meaningless, because an account is either a checking account or a saving account or an investment account, right? So in this case, but yet these are different type of accounts, but they still have, some things which are common between them, some common behaviors. So from that perspective, you will decide to create a parent class and you will decide to make them as abstract classes. And the moment you're going to make them in the abstract classes, you are actually telling to the programmer that you cannot create an object of it. As someone said in the beginning, like, is there any special notation for UML? Sometimes we use this tag as well, and sometimes italic as well. So sometimes, depending on the what you call the drawing tool. Some of them actually, make them italic. I can't really even draw italic here, but like, in a bit tilted way, right? Okay. So far, so good, guys?
Yes.
Okay.
Yes.
Yeah, italic, I think. Yeah, absolutely italic. Okay, now I will talk about the interfaces now, and then we'll do this, inshallah, an amazing comparison between, between the interfaces and abstract. And this is actually even more interesting from a design perspective. Are you able to see the screen?
Yes. Yes.
Yes.
Okay, great. Now, in this half of the lecture, right, inshallah, we'll try to cover some of the remaining fundamental concepts, which to do with your interfaces, your associations, and aggregations and compositions. And then there are certain topics like extension mechanisms and association classes and refined classes. Inshallah, I will talk about them on Thursday, and with that discussion, hopefully we will be able to complete the fundamental concepts of design. So let's focus on these ones today, right, in the remaining half of the lecture, and we can have some interesting observations and discussions here. So another related concept to inheritance is the concept supported by many programming languages, object-oriented programming language, and it's called an interface, right? Interfaces are usually created and they are very similar to classes, but they don't have any actual functionality in it. So don't really have any actual code, and they do not have actual behavior. Now, if they don't have a code, if they don't have a behavior, why on earth I need an interface?
I think
To make go ahead.
I think to have multiple inheritance to it. Because
Yes, so yeah.
the class we can only in child only have one class to inherit. At interface we can have multiple.
Yeah, so in case of Java, it supposes multiple inheritances with the concept of interfaces, right? But what exactly we need interface was for, because it doesn't have a code, it doesn't have, you know, any implementation.
Doctor.
Yes, go ahead, please.
I'm not sure, but I think interfaces provide functionalities to other classes. Like, for example, the comparable interface in Java. It makes classes which conform to it comparable. You can use them in if statements like greater than or less than.
Yeah, interesting one. Interesting one.
Doctor?
Yeah, go ahead, please.
Interfaces are used to enforce classes to follow a specific behavior.
Absolutely, absolutely. More like a contract, right?
Yes.
Exactly. Anybody else would like to comment on it? What exactly is an interface? We kind of summed it up, Muhammad. You know, yes, we don't have actual code and behavior, but it's all about the list of the method signatures, right? So we're going to have a list of method signatures, and you know, interface basically doesn't have any implementation, it doesn't have any behavior, but it will only have a list of signatures and their methods and their signatures. So something like this, right? So if I have an interface called printable, and then I can have, say, for example, you know, I have a method called print, and I have a method called print to PDF, and print method is void method, while print to PDF takes a file name. But what I'm still confused is that, okay, you can come back to me and say, well, Jazakumullah khair, Dr. Sujad, you're telling me that I can go and create an interface, and you know, I can have a print method and print to PDF method, but so what? Why exactly I need it? It doesn't have any code in it.
It tells me that if a class have an interface called printable, that means that that class must have the two methods in order to be printable.
Exactly. Yes, Abdullah, you're gonna say something?
Yes, I was going to say for polymorphism, for other classes to know and be able to use it.
Interesting. Yes, interesting. Abdul
One addition, Doctor.
Yes, go ahead, please, Ali.
Sometimes you want to create a class that combines two interfaces. For example, here, printable. If there is a class you want to combine a printable and, for example, readable. So you can create a class readable and create out of that one class that combines these two different interfaces as a one class.
Like implement these two interfaces, right?
Yes.
Cool. Abdul Majid says it's too easy to easily know the object have these methods or not. Absolutely. Right, so we're getting there, I think so. Yes, Jawad, you want to say something?
No.
Okay, so I think we're getting there. So in other words, it doesn't have any functionality. You are not allowed to put any functionality inside an interface. Of course, we just discussed about what's the point of it. The point is, or an idea is what? That if we create a new class and then choose to have an interface or implement that interface, it's like a contract, right? So what we are doing is we are promising to create methods with that particular name or signature. And of course, the class who is going to go on and implement this interface So whatever the class gonna go and implement my printable interface, it's just a promise that I will have these two methods. I will have the print method and I will have the printable print to file to PDF method. I have complete freedom over the way I want to do it in my class, right? But all we are doing is we're promising to do it, right? So it's like a contract, and that's the strength of it. So more the classes that implement the same interface, it's better for us, right? Now, let's look at an example here. So maybe you have a class called my class, right? And you are now going and implementing this printable class or interface. So will it have these two methods in it? Print and print to PDF?
Yeah. Yes.
Right?
Yes, of course.
Of course, because it's a contract, right? So I will have these two ones. The signatures have to be exactly the same, right? As defined in the interface. Implementation is specific to this case. So you're basically allowed to implement the way you like it, right? But I'm still confused. Okay, I can do it. But what's the design principle? What's the design benefit? Sorry, what's the really design benefit here for me? You can still argue with me. Okay, if I'm going to have my own implementation here, well, yeah, I understand that, I will have print and print to PDF and everything because I'm using an interface. But, at the end of the day, if I'm really going to have my own implementation, then why I should have this? Why don't I have just my own class?
Sometimes in the other classes, you are dealing with those objects from that class which implements the interface as if they are already implementing this feature.
Yes, exactly. So, for example, I have another class in the system now, right? And that class is actually, using my class, right? So, from a design perspective, the real benefit is what? The real benefit is, and let me delete this one. The real benefit is what? The real benefit is that if I'm gonna, use this class, and I know that this is implementing the printable interface, what I'm guaranteed from this perspective, from this guy's perspective, what I'm guaranteed? I'm guaranteed two things, right? That I will have a print method for sure, and I will have for sure a print to PDF method. Now, what is happening inside this is a black box to me from this guy's perspective, okay? He knows for sure that it will have a print method, and he knows for sure there will be print to PDF method. Now, how this is implemented, he knows it's good. If he doesn't know, it still doesn't matter to him. Because tomorrow, if I go on and change this implementation, will it have any impact on this guy? From his code perspective?
No.
No. Because, that's the black box to him. And that's the real strength of these interfaces. They are really, really useful for designers. Amazing tool for us. It helps us modularize our systems and kind of mask internal functionalities and reduce the rippling effect of changes and so on and so forth. So you will see again and again, as I'm going to talk about more advanced concepts of design in maybe a few weeks time, you will see that interface will show up again and again and again, and abstract classes, of course, because these are the two tools which you will use again and again to really achieve different design targets or principles. So they are really, really useful. So I think I asked this question anyway. What if I have these methods, right? So the real benefit is going forward, we can have many different classes to choose to implement the same interface. So you can have so many different classes, and you can have another class. You can have, another class called my class too, and there can also, go on and implement the same interface, and so on and so forth. So you are kind of guaranteed the signature of it's a contract, and you kind of modelizing your system. So for example, now other parts of application can use objects with interfaces without really knowing how these objects work. So basically, they don't care about how it really works. They only care about using them, and hence they are guaranteed that these methods will be there with these signatures. So they do not get confused, and they are guaranteed a certain kind of behavior, a certain type of behavior. Something like this, sometimes, later on when we have done this, what we have done here, we will say, okay, so suppose I have a bag of objects, a list of objects, and I'm going through it, right? So if I'm iterating through these list of objects, we can always say, does this object, support a certain printable interface? Like, for example, in this case, does it have, just a generic object? If it is an instance of printable interface, what's guaranteed then? What is guaranteed? I can go on and with confidence say generic object.print, right? And I will for sure have this print method available to me, isn't it?
Yes, of course.
Exactly. Or print to PDF, right? With that specific signature.
Yeah.
So as long as I can see that it's implementing the interface, I know I can go ahead and use it, with confidence. I don't need to know how it's implemented, but all I care is that I'll be able to print it, or print to PDF in this case as well, right? So I can go on and easily call the print method, and that's it. I might not know anything else. I might not know how it's been implemented, how exactly is the implementation detail, whether that implementation details have changed over 3, 4, 5 cycles or not. But all I know is because it's an interface and it's implementing that interface, I'm guaranteed these methods. So I know its print, I know its signature, I can easily with great confidence go on and just use it. Okay. So far so good. Yes, no, maybe.
Yes, good.
Yes.
Yes, yes.
Yes.
Okay, perfect, perfect. Now, I have a question. Of course, before that, since we asked this for the abstract class, in interface in UML is with this interface tag. Okay, and then you show the relationship, the one between your class and the class which is implementing your interface with the dotted lines. Okay, so it says that it's implementing it. Let me ask you a question here now. Same example, right? We had this bank account class example in the previous half of the lecture, right? And we had this abstract class, right? So remember, in UML, this will be italic, or sometimes some of the tools may use abstract as a keyword as well, or as a tag. And I have this bank, and then I have this saving account, and I have this checking account and investment account. And this is my abstract class. What's the difference between interface and abstract class then?
Abstract allows you to implement methods, write a code inside the class, the abstract class, as far as I know.
Yes, absolutely. It allows you to go and implement it, while on the interface, you cannot
have implementation.
Yes. No, when to use interface and when to use abstract class then?
Abstract class for more specific things, and interface for more general things.
Exactly. Abstract class is more like where you want to preserve, you want to structure inheritance relationship, Yet you want to guarantee that the parent is never initialized. There is no objects of parents. All right. Anybody else would like to comment on this difference between abstract class and interface?
Yes, doctor.
Yes.
One class can inherit multiple interfaces, but a class can, a class can implement multiple interfaces. But if a class wants to inherit from abstract class, it has only one. So.
Yes, exactly. And as Abdul Majid also said, abstract classes have attributes. Yes, absolutely, they have attributes. Yes. Right. Now, the good news here is that these two concepts, and this is the reason I covered them here, is that these two concepts are amazing tools for you as a designer when you're going to try and achieve good designs. Believe me or not, most of the times you can easily use interfaces and sometimes abstract classes to come up and satisfy bulk of good design principles, because they kind of segregate, especially the interfaces kind of make it black box, segregate the different aspects of the application from each other to avoid impact of change and so on and so forth. So these two concepts are amazing concepts. You're going to see them again and again, especially in 2 to 3 weeks times when I'm done with the architectures and I'm more into detailed designs. You will see in good design principles, you will see them in design patterns again and again and again. And they are amazing and fundamental tools to you as designers. Okay, so inshallah, as we move along and we come to that stage, I'll talk about this in more detail with different examples. But believe me or not, mark my words, you will see them again and again. Okay, so far so good.
So far, so good.
Yeah, good.
Yes.
Cool. And that's why in design pattern, as I just said a minute ago, Gang of Four is a very famous design pattern book, and basically they say program to interface, not to implementation. In other words, create interfaces, mask the internal working of the application, part of the application, and let other classes talk to each other through interfaces and so on and so forth. And they of course have come up with a range of design patterns which can be really useful to improve your design structure. What they are, how they look like, how I implement them. Inshallah, we'll talk about this in maybe 3 to 4 weeks time, inshallah. So just to complete these fundamental discussions on design, we started for the last maybe 4 or 5 lectures. We have associations. I'll just breeze through it because I'm pretty sure you guys all know it. So for example, customer can have an association with the shopping cart, and shopping cart has a relationship with item. So why can't I have an inheritance relationship between shopping cart and item? Because item at the end of the day is included in a shopping cart. So why not I do this?
Because an item is not a shopping cart, not the same type.
It's not the same type. Absolutely, it's not the same type. It's not this case, right? It's not like checking account is the same type as bank account, right? They are of the same time. That's why you can go on and create inheritance relationship between them. But here you cannot, because they are not of the same type. They have some relationship for sure, but it's not an inheritance relationship. So it's basically has a relationship, and we're going to model them as associations. Or like an has a relationship. And some examples could be a customer has an address, and a car has an engine, a bank has many bank accounts. So basically, this was the case we saw in the first half of the lecture, right? Where I was trying to make an inheritance relationship between bank and bank account. Of course, they have some relationship, and that relationship is an association relationship. University has many students and so on and so forth, right? What's aggregation, guys?
It's a part of relation, which means that a student is a part of the classroom.
So student is a part of classroom. What about this one?
Limitation of numbers, which means many students in one classroom, but a classroom, yes.
Or a classroom has many students, yeah?
Yeah.
Anybody else would like to comment on this?
A student may be 0 or more. Classroom might be or should be 1 or more, or only 1.
I think this is a weak association, I think.
Okay, now what is, we'll talk about this in short. What is composition then? Composition is more like a specific part of kind of an aggregation, right? It implies ownership. So what this one tells with the black dot?
It means that
it's like the document is composed of pages. So if the pages go, there is the document.
Yes.
Anybody else?
I mean, without page, we cannot do document. That's fine.
Yes. So for example, if we have a document and document class and a page class, right? Document objects will be composed of page objects. Okay. So this is the way you read it. Document objects will be composed of page objects, and of course, when an owing object is destroyed, so are the contained objects. So if I destroy document objects, what will happen to the pages?
Disappear.
Yeah, we need to delete them.
Useless.
Say it again, please.
Will be useless.
It will be useless. Yes, exactly. So it still has a relationship. There is no doubt about it. It's still the same has a relationship, and so a document has pages, right? But as a designer, you're telling me, or you as a designer are telling me as a source code writer that if you're gonna delete document object, then all the associated page objects needs to be deleted. Okay. Now, aggregation usually is not that worth showing on a diagram. It's really, yes, we can show it and you can still, have it, and this is nobody's stopping us from using it. But to be honest, it's the composition which we are more interested in. Why? Why it's important for you as a designer to show composition if you believe there is a composition relationship?
Doctor?
Yes, go ahead, please.
I think this benefits in memory management. If a developer does not want to make memory leaks, this would be very beneficial to prevent the retain cycles.
Exactly. So you want to kind of make sure that, if one of them is deleted, the other one is also gone, right?
Yes.
Is everybody comfortable with these concepts? Because I want you.
But
yes, Saud.
Can you please explain more why we are like interested in composition than the other one?
Than the aggregation one, right? Okay. So see, the reason we are interested in it is because during the lifetime of an object, it depends on another one, right? So it's worth showing it. So for example, in this simple case, if we are defining the document class, we might need to write the constructor and destructor, which will make sure that, for the creation and deletion of the internal objects, right? So for example, in this case, since document has a composition relationship with page, this means, and you believe it's a composition relationship, and because a document without pages doesn't make sense. So you will model that as composition. And as a result, when I'm going to go and write a piece of code, I'm going to make sure as part of the constructor that I go and create a page object if it doesn't exist. And I'm going to use, for example, as part of the destructors, I want to make sure that I go on and delete them if the document object itself is deleted. Right. And of course, from a low-level memory management perspective, that makes sense because you don't want, for example, since you know that in your application, document without pages are meaningless. Hence, I should not be left with so many pages in my memory while I have no document. Is this clear?
Yes, thank you.
You're welcome. So, how much time we have, guys? Maybe 1 or 2 minutes to go, right?
Right.
Yeah, 1 minute.
Yes, okay. 1 minute, yeah. So basically, I'm stopping here, inshallah. I'm gonna let me stop the recording and take the attendance, right? Feel free to raise a question if you guys have, right? And